What's up? Welcome back. Tutorial again. And here we are, back with another problem. Problem number 2. Still on simple stresses. But this time, it's normal stress on members of a truss. Let's go.
Yeah, man, it's just on an heavy roots.
Problem number 2. For the truss shown, calculate stresses in members DF, CE, and BD. The cross-sectional areas of each member is 1,200 millimeters squared. Then indicate whether it's tension or compression. So we are tasked to find what's the stress of this member BD, this member DF, and this member CE. So in order for us to find what's the stress, we must know the two parameters, which is the force and then the cross-sectional area. And since we're already given with the cross-sectional area of each of the members, the only job we're going to do in this problem is just to find what's the force on that members. So that's the only job we're going to do. So if we start on finding what's the force on member DF, we can find it by doing method of joints on the point F. So but first, we must know what's the reaction of this roller for us to find what's DF. So if we draw the free body diagram of this system, it will look like this. Here's the thrust, the loads, and then here's the reaction. So to solve for the reaction, just have to sum all the moments on point A and equate it to 0. And if we assume counterclockwise as a positive, we'll then have 0 is equal to, since RF turns the whole system counterclockwise, therefore RF is positive. So just to check if this is true, 180. So that's 4 plus 3 plus 3 is equal to 10. So that's going to be 10 RF. And then 200 times the distance would be 7. But then it turns the system to clockwise direction. Therefore it's negative. So that's going to be negative 200 times 7. And then the 100 kilonewton force times 4 and would turn the system clockwise. So still negative 100 times 4. So if we simplify that, adding 200 times 7 and 100 times 4 on both sides of the equation, then dividing it by 10, we'll then have 200 times 4 plus 100 times 7 over 10. Oh no, it's actually 100 times 4 and 200 times 7. We interchange 7 and 4. And it's indeed 180 kilonewtons. The reaction on F. Now that we know what is the reaction in the roller support, we can draw the free body diagram of point F so that we can now know what is DF. So here, you might wonder where this 4 and 3 came from. So that's for 3 is the slope of this DF. So if the height of this to this is 4, that would be the rise of this DF, the slope of DF, and it will be 3 be the run. So that's why there is 4, 3 as slope there. And if we take the square of both 4 and 3, add together and take the square root, or in other words, the Pythagorean theorem of that, this side would be 5. Now, if we take the sum of the forces in the y direction equal to 0, we can then have 4/5 this, because it's the vertical component, 4/5 of df equal to 180. I equate directly 180 and the vertical component of this df because it's the only forces acting on that point. So df should be 180 times 5 divided by 4. 180 times 5 divided by 4. So it's 225 kilonewtons. 225 kN. And we are also tasked to indicate whether it's tension or compression. So since here our arrow is going down, therefore it's, or going to the point, that's compression. Or else if it's not, it's like that, that should be in tension. Since that's going to the point, this df should be in compression. And if we sum all the forces in the x direction, the horizontal component of df should be equal to ef. ef that is in tension. So 3/5 of df is equal to ef. 3/5 of df is equal to ef. Therefore, ef is equal to, we know that df is 225 kilonewtons. So if we substitute that here, 225, and then multiply both sides by 5/3, then ef should be 225 times 5 divided by 3 times 5 divided by 3. So 375 kilonewtons. ef is 375 kilonewtons, and as we can see, it's in tension. Kilonewtons in tension. So now that we know what's the force in df, and we're also provided that the cross-sectional of each member as 1,200 millimeters square, we can now solve for the stress in df.